welcome to the Math Methods podcast. In this episode, we're looking at cubic functions. So we're looking at how we can actually expand cubic expressions, how we can factorize cubics, and also how we can graph cubic functions. So let's get started. So let's start by looking over how we expand expressions, and we deal with cubics in exactly the same way that we dealt with quadratic expressions. So each term in the bracket must be multiplied by the terms in the other brackets. For cubics where you've got 3, where you do with 2 of those first and then you multiply by the third. So let's just have a quick look at how it works for quadratic functions. So we've seen this in our previous podcast. We've got a pair of brackets, x minus 1 multiplied by x plus 5. We're going to multiply the x by x and 5. We're going to multiply the minus 1 by x and 5. So what we'll end up with is 4 terms. You'll notice that the 5x take away x gives us just one term. So x squared plus 4x take 5 is the expansion of those brackets. We do the same thing with cubics. We deal with 2 brackets first and then we multiply by the next term. So here we're going to multiply these 2 brackets. So 3x squared take 12x take x plus 4. 3x squared take 13x plus 4. Now we've still got the x out the front, and that just means we multiply everything inside that bracket by x. So 3x cubed take 13x squared plus 4x. Next one's slightly trickier because we've got 3 whole bracketed terms here. Again, we're going to deal with 2 starting off. So I've taken the last 2, give us 2x squared plus x take 1. And now what we're going to do is look at multiplying by the x and by the minus 4. So by the x, we get this one, 2x cubed plus x squared take x. And by the minus 4, we get this one, 8x squared take 4x plus 4. We simplify by grouping the terms. There's the x squared terms we can group and the x terms we can group. And this is our final result. Y equals 2x cubed take 7x squared take 5x plus 4. Now there is a shortcut here that is worth looking at. If you've got a perfect cube, so a plus b all cubed, the end result we're going to get is a cubed from the first term, b cubed from the last term, and we're still going to get 2 middle terms. We get an a squared term with a b. We get an a term with a b squared. So notice this is symmetrical on both sides here because a and b, there's nothing special about one or the other. But what we get is a plus b all cubed, giving us a cubed 3a squared b, 3ab squared plus b cubed. Now, the reverse of expansion is factorisation. So let's have a look at how we actually factorise. If we were to factorise a number, we'd be dividing. We know a number that divides into it, and we find what else divides into it. We do exactly the same thing with polynomials. If we get a 0 remainder, what it tells us is the divisor is a factor of that polynomial. So, for example, if we divided the number 72 by 8, what we'd get would be 9 and a remainder of 0. It tells us that 8 is a factor. If we divided by 10, what do we get? We get 7 and we get a 2 left over. It tells us 10 is not a factor. So we're going to use that idea with factorisation to try and get a 0 remainder, and that tells us what we found is a factor. So we write it out in the same way that we'd write out a long division. X minus 3 is what we're dividing into. X cubed minus 4x squared plus x plus 6. So we start with the question of what is x cubed divided by x? How many x's are there in x cubed? And the answer is it's x squared. Think about numbers. If you had 2 cubed, which is 8, divide it by 2, you get 2 squared, which is 4. So we're going to put this x squared lined up with the x squared below that. We're going to keep the columns lined up like you'd line up your powers of 10 if you were doing a long division. We're going to line up the powers here. So we'll put the x squared up there. Now that we know x squared, we want to find what the remainder is. So we multiply back down again. X squared by x gives us x cubed. X squared by minus 3 gives us minus 3x squared. So we multiply back down and we find the remainder. Now notice that there was no x term or number terms. We just put those as zeros. We subtract these two lines to find the remainder. And we get this. Minus x squared plus x plus 6. So minus 4x squared. Take away the negative means add. We get minus x squared. X take away 0x. We're still left with x. And likewise 6 take 0 is 6. So let's have a look at the next one. How many x's are there in minus x squared? Well, the answer is it's minus x when we do that division there. Goes up above the x's. Minus x by x is going to give us x squared. Minus x by minus 3 is going to give us positive 3x. Again, we don't have a number term at the end, so we just put a 0 there. When we subtract these two to find the remainder, we now get minus 2x plus 6. So lastly, minus 2x divided by x is minus 2. Put it at the top. Minus 2x and 6. Subtract these two to find the remainder and we get a 0. So what it tells us is x squared take x take 2 is our last two factors that we need to actually find. We know that x minus 3 is a factor because we've got a 0 remainder, and we've now got these two factors for us to find. So x squared take x take 2, you can further factorize as x minus 2 and x plus 1. Think back to what we did with quadratics to solve that one. So we now know that this cubic function has indeed got three factors: x minus 2, x minus 3, and x plus 1. So we use this idea called the factor theorem to actually let us find these factors. And if we've got a factor, then what we know is we get a 0 remainder. And the other thing we know if we've got a factor is we can actually find the intercept for the graph. So if we've got a factor, well, let's call it x minus a, then we know that dividing by that factor will give a remainder of 0. We also know that the value the function has, what we call p of a, is going to be 0. So if x minus 2 is a factor, when we put x equals 2 into the polynomial, we get a 0 out. And that, of course, corresponds to an x-intercept on the graph. So we can use this idea to find the first factor, and you can actually use it to find more factors as well, but we tend just to find the first and then divide to find the remainders. So let's have a look for an example at this cubic function. X cubed take 4x squared plus x plus 6. And look at the values of x and values of y. So notice when we put minus 1 into the equation, we get a 0 out, and that tells us x plus 1 is a factor. 2 and 3 are also giving us the intercepts. So here's what the graph looks like. X is minus 1, that tells us x plus 1 is a factor because we get a 0 coming out from that. When x is 2, we get a 0 coming out, so x minus 2 is a factor. And likewise, x minus 3 is our third factor. So the intercepts are at minus 1, 2, and 3. Anyway, let's have a look at how we graph some cubic functions. Now, the first one we've got here is actually given to us in a factorized form already. If it's not, then your first step is to find those factors. But just looking at the graph here, we've actually got three factors. We've got minus a half x, we've got x minus 3 and we've got x plus 2. So 3 factors will mean 3 x-intercepts. So the steps that we use the factor theorem and divisions to get to this stage. Once we've got it factorized, then we've got to solve for where y equals 0 to find what the x-intercepts are going to be. Lastly, to find the y-intercept, it's the reverse. We put x equals 0. So starting with your x-intercepts, y equals 0. The first one we've got here is at x equals 0. Half x equals 0, so x equals 0. X minus 3 equals 0, so x equals 3. And lastly, x plus 2 equals 0, so x equals minus 2. We get the y-intercept by putting x equals 0 into the equation, and for this one, we get y equals 0 coming out. Now this cubic's a little bit different because you'll notice that it only actually has 2 points where the graph is in contact with the x-axis. We've got one intercept and we've got one turning point on the axis. And that's because we've got a repeated factor. So the x minus 2 squared gives us a turning point at x equals 2. The other factor, of course, we've got is x, and that gives us an intercept at 0. The y-intercept for this one is also going to be 0. Put x equals 0 in, and you get a y equals 0 coming out. The last thing to keep in mind with this graph is it's actually an upside down cubic. It's one that's headed predominantly downwards, and that's because of the negative sign out in front. Now the last cubic we're looking at here is a special type of cubic where we actually have got what we call a point of inflection. And you can see these, what makes these ones special is they have the repeated cubic term in there. So x minus 1 cubed, that's the clue that we've got an inflection there. Now where the inflection is going to be is 1 unit to the right and 2 units up. Think back to what we did with quadratic functions, and it's exactly the same. Solving this to make it 0 is moving 1 unit to the right, from x minus 1 all cubed, and it goes up 2 units. So there's our inflection point. We still need to find our y and x intercept. So the y-intercept is where x is equal to 0. So we put those numbers in, and what we get is we get 2, take away 1/5, which as a decimal is going to be 1.8. You can see that there in the graph. The x-intercept is where y is equal to 0. So 0 equals 1/5 x minus 1 cubed plus 2. We need to do a bit more work to actually solve this one. What we end up with is we bring the 2 across and divide by a fifth. We get minus 10 equals x minus 1 all cubed. To solve that, we need to take the cubed root of minus 10. Remembering we can't take the square root of a negative, but we can take the cubed root of a negative. So cubed root of minus 10 plus 1, end result is minus 1.15. So hopefully you've learned something there about cubic functions. Keep up the good work, and we'll catch up next time. Bye.